Now I don't know what these choke values should be, but like I said, I would guess they'd be somewhere in the order of a few hundred ohms. Let's see if we can figure this out. So we got one going right to the rectifier tube. That's got to be this lead right here. So let's get a clip on that. And the other side goes to this box, which has got to be this right here. Yeah. .4K. Okay. It's a little more than I was expecting, but it doesn't mean anything. I really don't know what the value is supposed to be. And the other one should be from the same side here over to this point, which is the other cap. Just got to be this point. Okay, 500 ohms seems reasonable. And the final one is internal to this, and it's just between these 2 points. So from there, I actually had that one wrong. Hang on. Okay, 700 ohms for this guy. And now I want to go from that point over to here, and this is that final output L1 here. Ooh, that doesn't look good. I double checked that output coil resistance following this diagram, and I got a reasonable value. If I compare the two side by side, you can see they're not the same. Both have 2 capacitors on the right, joined in the middle, but this has the output coil going from the upper left to bottom right. This has it going from the upper right to bottom left. Now, I know this is upside down, but if I put it right side up, it's complete nonsense. All I can think is that maybe they're a mirror image, and that one is a top view and one is a bottom view. I don't know. All I know is that if I follow this and just consider this to be the bottom view, everything seems to check out okay. So all the resistors and coils seem to have reasonable values. So I now took out my solar capacitor bridge, and let's check out some of these caps. Right now I'm trying to check this, the 0.5 microfarad output coupling cap, which is these 2 connections here, one of which is going right over here, so I just clipped a lead on there. Other lead is clipped down here, and let's first just check for leakage. And not too surprisingly, the light's flashing. We've got leakage. For the heck of it, I'll try to check the capacitance. So we should get an eye deflection around 0.5, which is way down here. And we actually do. I actually do get a full eye. I'm going to cut the lighting so you guys can see that better. Okay, so as I rock this dial, we do get a full eye opening right about there and over on the dial. It's right at the edge, but it is around 0.5, 0.6, 0.7. So we do have capacitance. This is just very leaky. Well, let's check one of the other guys here, which should be 1 microfarad. These are the filter caps. Now that's off the range here, so I'll have to go to the C1. Checking the capacitance first. And we do get an open eye. It's not a very wide open eye, which generally means it's a leaky cap. But right around there, which is the outermost red scale, just about 1.5 microfarads. If I check this for leakage though, oh yeah, leaky. The faster the light flashes, the leakier the cap is. So this is flashing a lot faster than it was when I checked the 0.5, so I'm not surprised when I checked for capacitance I did not get a very distinct eye opening. So what does all that mean? Well, it would probably kind of work if I powered this up. Capacitors are somewhat leaky, but not a dead short. They still have some capacitance. What would happen is they would probably act as a bit of a load. They would get kind of warm. They would drag down the voltages. In other words, they'd be working as a very leaky capacitor. Now, if these were electrolytics, possibly I could leave this on for a while and the capacitors would reform, the light would start flashing less and less frequently, and it might go out altogether, in which case the capacitors would possibly be usable. But since these are tar caps, I don't think that happens. But I'll leave this on for a little while, 5 minutes or so, just to see if there's any change in the frequency of that light, but I really don't think there will be. Which means I am going to have to recap this. Somehow I've got to figure out a way to replace these caps that are inside of this box while preserving that coil's functionality. Now it seems to me that all I'm going to do is disconnect the wiring to these points and wire them to some external caps mounted out here, and there won't be any problems. Unless possibly maybe there's some conductive path between this coil and the outside of the case, or through this cap to the other side. Probably not though, probably be okay. Not surprisingly, after a few minutes the light is blinking just as rapidly as it was before, so these caps definitely have to go. However, that doesn't mean that I can't proceed with trying to power this up, because I'm going to do it with the rectifier pulled out, which means there's no way for voltage to get over to here, to this cap, and this cap is only for the speaker coupling, which I don't have connected, so there's no way of any voltage going on any of these caps. What I want to test for is that we get 5 volts VAC here, and these voltages, well, we won't get DC, but I should get these voltages AC here. I won't get DC, of course, because the rectifier tube's pulled. Now, without knowing exactly what the normal load is on what these and what the resistance is, it's a little hard to guesstimate from 165, working backwards, what the voltage should be here. Probably something like 200 to 300 volts on either side of the center tap, I would guess. So that's what I want to check for. Before I can do that though, I need to wire in a power cord, and because I don't trust the switch, I'm going to wire one side of the power cord right to that point, which I determined earlier was the 120 volt position. Before I try powering this chassis up, I thought I would take a quick peek at this one. Right now I've got the ohm meter across the 16K resistor, and we're measuring 17.4. I've already checked what marks here is 43K, and I've got about 30K, so a bit off. Which just leaves this guy. She says should be around 5 meg. That's this odd looking one here that's got all this junk flaking off. And let's see, not so easy to find a place to connect the probes on it. I'm going to put down the camera while I hunt around for a good place to test it out. Okay, we've got about 8 meg on that resistor, so that'll have to be replaced. Now these other goofy things that I thought might be resistors at first are actually capacitors. I do not know what the value is on those. I will just check to see if they're shorts, and if they're not, I'll assume that they're close enough and just leave them alone. Which leaves the caps inside here, which are these guys. I think it's pretty safe to assume that those are bad, and those will need to be replaced. And then there's this guy, which I've heard has a tendency to go open. It's a big wire wound rheostat there. That's this guy on the antenna. So I'm going to test that. I don't recall exactly what the value is supposed to be, but if it's bad, I imagine it's going to measure open. Like that. I seem to have solid connection. Just shorting out the probes, and yeah, we got all zeros. We go to the other lead the rheostat, got nothing. Center, nothing. Alright, so that will require a little more examining. Maybe the brake can be repaired, otherwise I'll just have to replace the whole thing. Okay, I've got a 60-watt bulb in series with the line cord. I got my variac dial down to I think around 90 volts AC according to the dial. And I've got my meter on these two terminals here, so we should get something around 5 volts. I'm turning on the variac now. Alright. Nothing's exploded. The light bulb is not lit up. So, and oh, and we've got a bit less than 5 volts, which is what I would expect since I got my variac turned down a bit low. Crank it up a bit. We are right on 5 volts. Now let's check the other guys. We should have 2.25 and 1.5. That's for the various tubes. The assortment of tubes they use run on somewhat different voltages. 2.4 and 1.6. Alright, I'm concerned there's no load on this. I'm not that surprised the voltages are a little screwy. Now, last thing to check is the voltage on the plates of the rectifier there. For that, I need to, I'm going to turn this off and then securely connect the meter leads. We're talking hundreds of volts here, so I don't want to slip up while it's turned on. Okay, I've got my meter connected on one side to the chassis, and the other side is going to one of the plates on the rectifier. And here goes. Alright, 292 volts. Cool. Just like I was guesstimating, it'd be somewhere between 200 and 300 volts, and there we are. Now I will move my meter lead after I turn this off and check the other side. I've repositioned my leads to the other side of that secondary winding, so let's check it out. Excellent. Same as I measured on the other side of the center tap. So, as nasty and grungy and corroded and dirty and full of cobwebs this radio may have been and may still be, every component I've checked other than the capacitors, which I would expect to be bad, and the antenna rheostat have checked out good. So I wouldn't be at all surprised if I were to pop in a few new caps and replace that rheostat and power this radio up right now. It would work. Except for one thing, I do not have a speaker that's compatible with a radio like this. For that, I'm going to have to hunt around and ask around online. But I will show you briefly what the possibilities are. This Brunswick 5KR inside is identical to a Radiola 18. So what I've pulled up is the type of speaker that would have come originally with a Radiola 18. The basic choice was the model 100A speaker, which is this guy. There's a number of examples on this Google image search I've done. The earlier model was the 100. The 100A has a superior sound reproduction, or so I've read. Now, if you got a few extra bucks to spend, you can get the 103. Let's see if I can pull up a better picture of that. I'd love to get a 103 if I could. There's one on eBay right now, but I suspect it's going to go for quite a bit. The 103 is made of a pressed material, I think called rep wood, which is like sawdust and glue and such. You'd press into a mold and made this cool octagonal frame, and then they put this tapestry grill cloth of a vase of flowers inside. And from the back it's got this nifty silk bag wrapped around to protect the speaker from dust. Now, if I really want to be authentic, I could go for a Brunswick speaker. That's what you see in this picture here. I think it's called the Model A, which comes in its own rather fancy, elaborate little wooden cabinet. It looks like a radio in and of itself, but it's just a speaker. Never seen one for sale. Not that I've been really looking for long, but you can see it's got the 5KR right underneath it. So I imagine that's what they originally sold as. I'm also just realizing how big that speaker is. It's almost as big as the radio underneath it. Now realistically, I'll probably end up with a 100 or a 100A. I've seen a few on eBay. I'll throw in some token bids, and I'll ask around with the other radio collectors on the Antique Radio Forum, or more likely than not, I'll get one from one of those guys. Or if any of you have one for sale that's compatible with this radio, please drop me a message. One last thing I wanted to do in this video was test the tubes, and unfortunately it's a real mixed bag. The one I was most concerned about was the 71A. Not impossible to find, but in the globe form, little expensive. And it just so happens I have a spare, but I was really hoping this would test good. And it did for a while, but then the filament went out. So maybe there's a loose connection in the base. I don't know. You can hear something rattling around inside, but it's most likely bad. The 26s, one really weak, one has shorts. This one I just popped in the tester. No shorts. And it's just at the edge of the replace zone. So I've yet to find a tube that's actually really good in this radio. So it looks like not only do I need to track down a speaker, but I need to track down some tubes. I think I've got some 26s, but I'm not positive. I know I've got a 71A. And I definitely have some spare 27s. And I've got one, probably 2 or 3 spare 80s. No spare 80 globes, though. 80 globe tubes, I just can't believe it. How much they're selling for these days. $50 would be a bargain from what I've been seeing on eBay lately. Hey, best tube so far. It's right in the question mark. Guess that's it for the 26s. The only tube I have left to test is the 27. Oh, by the way, I did test the 80, and the 80 is actually pretty good. I forgot to mention that. Let's see, 27, 1, 6. Very important to check the filament and double check it because these tubes all vary. The 26s run on 1.5, the 27 runs on 2.5, the 71A runs on 5, the 80 runs on 5. Do not want to burn out a tube by having the wrong setting. 40, 4, alright. Oh, and yeah, it's a B socket. Lit right up, it's a good sign. No shorts. Hey, the first tube that's been in the green other than the Type 80. Alright, so a mixed bag, but certainly none of the critical components are bad. So I'm going to reassemble this set and put it on the back burner while I hunt down what I need to fit to get it running. Hope you enjoyed this video.